Hi guys, my name's Lindsay, and today I want to take a look at a couple exponent rules with you. So I've sort of summarized them here on the side for you, and we're going to kind of go rule by rule, define it, and then we'll do an example question of each. So we're going to start with the product rule. The word product just means multiply. So you can see here I've got x to the power of 3. That dot means times, because if I wrote an x for times, that would look like a lot of x's. So x to the power of 3 times x to the power of 5. And basically, let me grab pink here so it's a little clearer. Basically, all the product rule says is if I have bases that are the same, the base is the x, so they're both x's, then my answer is going to have a base of x. And all I'm going to do is add those two exponents together. 3 plus 5 is 8. And we're done. There's no need to expand those values. That would take a really long time when the rule tells us that we can just add those exponents. So let's take a look at an example of that using real numbers. So let's start a little bit higher here. If I had 3, for example, to the power of 2 times 3 to the power of 7, instead of figuring out what 3 to the power of 2 is, and 3 to the power of 7 figuring out what that is, and then multiplying those two, especially that one would be a really big number, multiplying those two numbers together and getting the answer, I can actually just write my answer as 3, because both of those are 3, and then I'm going to add my exponents. So 3 to the power of 9 is my answer. Now in my calculator, if I wanted to figure out what 3 to the power of 9 is, I can, or I could just leave my answer like that. It's kind of a little bit more simplified. So let's take a look at the second example I've got up here. Second rule, quotient rule. Basically, quotient just means divide. And I've used y because the base doesn't matter, so we'll use different bases all the time. Y to the power of 5 divided by y to the power of 2. A lot of the times you're going to see division questions, especially in algebra, written as fractions. But y to the power of 5 divided by y to the power of 2, those both mean the same thing. Don't be thrown off because it's a fraction. A fraction is just a division question. And the rule, the quotient rule, tells us that when we have bases that are the same and I'm dividing, I'm going to have an answer with the same base, and I'm just subtracting this time. So 5 subtract 2 is 3. So y to the power of 3 is my solution in that case. So again, really straightforward. You don't have to struggle too much. You just subtract the exponents. Let's look at a real life example here of that one. And this time, let's write it as a fraction. Let's say 2 to the power of 9 divided by 2 to the power of 6. And again, instead of figuring out what that big giant number is and then dividing it by another really large number, I can use that rule to leave my base the same and subtract the exponents. 9 subtract 6 is 3. And then, if you wanted to, since this one I don't need a calculator for, 2 to the power of 3 is 2 times 2 times 2. I could write that answer as 8 if I wanted to. I can do the same with that one up there. So let's take a look at a third example here. This one's called the power rule. We're dealing with two powers, two exponents in this case. And the rule here is that, again, my base, that's a z. The reason I cross it is so it doesn't look like a 2. So that's a z. I've got z to the power of 3 inside the bracket, and then I've got z to the power of 2 on the outside of the bracket. And instead of expanding that whole thing, all I need to do is use this power rule and multiply those two values together. 3 times 2 is 6. And I'm done. So again, let's go over to a real life version of this. So let's have 5 to the power of 4 to the power of 10. Doesn't matter what our numbers are. We're just going to multiply them. And again, I could find out what 5 to the power of 4 is, and then I could multiply that times itself 10 times. But that's a whole lot of work and a whole lot of math. And instead, I can just leave the base the same and multiply those two values together. Now I've got 5 to the power of 40 as my final answer. And again, find that value out at this point if you wanted to, or you could just leave it like that. It is a good final answer. And the last one I have here on the list is negative exponents. And I have two examples just because I wanted to not forget that second guy down there. But I'll start with this first example that I've got written here. Let me do that one in pink. So I've got x to the power of negative 2. Now, final examples in math should always be written the most simplified form. And in the most simplified form, we shouldn't have any negative exponents. So if you have a final answer with a negative exponent, here's how you deal with it. You take that base, that x value, I'll deal with this guy in a second. Take this x value, and we are going to put it on the bottom of a fraction with a 1 on top. And now instead of having that negative 2, I can give it its exponent, except that I can change that negative to a positive. So x to the power of negative 2 is the same as 1 over x to the positive 2. So I've just moved it from the top of a fraction down to the bottom. So let's make a real life example of that one, and then we'll go over to this guy and check that out. So let's say that my real life example, let's use 2 because that kind of makes our lives a little bit easier. 2 to the power of negative 4. And 2 to the power of negative 4, I don't want my final answers to be negatives with negative exponents. So I am going to put this as 1 over 2 to the power of positive 4. And then at that point, if I wanted to simplify it further, I could. So 2 to the power of 4 is 16. And if you were to type this into your calculator, 2 to the power of negative 4, you'd get a tiny little tiny number because 1 divided by 16 is quite a small number. So let's take a look at this guy now. I threw him up there because I didn't want to forget an example like that. So I've got 2x to the power of negative 4. And the reason I wanted to visit that value is because this to the power of negative 4 is actually just sitting beside the x. It has nothing to do with the 2. The 2 is just multiplied by x to the power of negative 4. So I'm going to use the rule I did here. I'm going to put a 1 over top of the fraction. This x, though, is the only thing that goes down here. And then that gets flipped to a 4. And actually, let me just rewrite this a little bit differently. That 1, I'm going to take that guy away. Since this 2 is not attached to the negative exponent, the 2 can stay on the top of the fraction. And just this x goes down to the bottom, and now his exponent gets flipped. So hopefully that one makes sense as a final answer, and hopefully these other guys kind of do too. We're getting a little messy here, so I'm just going to give you your final answers there. So those are your basic exponent rules, the product, quotient, power rule, and negative exponents. And one last guy I just want to throw up here for you is a zero exponent. And this guy's kind of cool because he's got a very consistent rule. And the rule is that anything, so let's use a value, anything to the power of 0 equals 1. It doesn't matter what that number is. Now, what if that example was a variable? What if it was an x to the power of 0? I don't know what x is, except that x is still a number, and any number to the power of 0 is 1. So even if our value is a variable, it's an x, a y, a z, something we don't know, as soon as it's to the power of 0, the answer is 1. So it's kind of a special little rule. So hopefully that clarifies for you just the basic exponent rules.